Hello, welcome to our next lesson in our perimeter and area unit. Today's lesson we'll talk about arc length of a circle. Alright, first thing we want to go ahead and do is let's go ahead and define what an arc length is. An arc length is going to be a portion of the circumference of a circle. So in this circle that I have up here, the red outline of this represents the circumference, the total distance around a circle. The length of the arc is going to be the distance between 2 points on the circle. So if I call this point A, and let's say I call this point B, okay, the arc length is going to be the part of the circumference between points A and B. So the length of that part of the circle, part of that circumference from A to B. Now, because arc length is related to circumference, it's a piece of the circumference, okay, we're going to use ratios to figure out the length of an arc is. So in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360. So this proportion, remember a proportion is when I have two ratios equal to each other, represents the relationship between arc length and circumference. And it has the same relationship as arc measure to 360 degrees. Now we remember that the circle, all of the interior angle measures are going to add up to 360 inside of a circle. And so it's going to be proportional. The arc length to circumference is proportional to the arc measure to 360. Now as far as this proportion is concerned, we can find any one of these three things: arc length, circumference, or arc measure. The one thing that will remain constant and will always be a part of this proportion is going to be this number right here, 360. So depending on what we're looking for, whether we're looking for the arc length, circumference, or arc measure, we will be given two of those three things and asked to find the third. Like I said, 360 will always be on the bottom right part of the proportion. So let's take an example of what something like this might look like. Using the diagram to find the indicated measure, we want to find the arc length of RS here. And actually what I think this problem is asking us to do, instead of finding the arc length, we want to find the arc measure. So what that is going to be, that's going to be the measure of this angle that goes from here to there. We want to find out what the measure of that angle is. So we're going to go ahead and use our proportion that we just talked about. So remember, we've got arc length over circumference equals arc measure over 360. Now it's important to identify what are we looking for and what am I given already. So we're looking for the arc measure, so my unknown is going to be right here. So if I want to go ahead and start writing my proportion of my own, we're always going to have one fraction equal to another fraction. The bottom right number will always be 360, and we need to fill in the other three. Arc measure is what I'm looking for, so I'm going to go ahead and call that x. That's my unknown. I don't know what the arc measure is. So I should know what the arc length and the circumference are. So if we go ahead and start with arc length is going to be the distance on the circle from R to S. And we're given that that is going to be 38 feet. So 38 is going to go on the top left of the fraction on the left-hand side. Now on the bottom, we're going to put the circumference. Now we're not given the circumference of the circle, but we are given 12.3 feet, which represents the radius of the circle. So let's go ahead and find what the circumference of the circle is going to be. So we know that the circumference is equal to 2 times pi times my radius. We'll go ahead and leave pi as a variable for right now. So it's going to be 2 times pi times my radius, which is 12.3. Go ahead and plug this into my calculator. And I'm going to get 24.6 pi is my circumference. So this is my circumference. This is going to go on the bottom left-hand part of my proportion. So 24.6 pi will go right here. Now this is a proportion, one fraction equal to another fraction. In order to solve a proportion, we are going to cross multiply. So that means we go x times 24.6 pi, which is going to give me 24.6 pi x. And that's going to be equal to 38 times 360, which is 13,680. Now we want to isolate x. So that means get x by itself, which means I need to get rid of 24.6 pi. So I'm going to divide both sides by 24.6 pi. On the left-hand side, this is going to cancel out and leave me over with x, which is what I want. And on the right-hand side, I'm going to do 13,680 divided by 24.6 pi. Now again, I want to be careful with this. I want to put it in parentheses. So we get 24.6, and we're going to go ahead and use the pi button. So for a second, and then this caret right here will give you that pi button right there. We want to make sure we put in parentheses to make sure we get the correct answer. So 13,680 divided by 24.6 pi, press enter, and you're going to get 177.01. We'll go 2 decimal places with this one. So x is going to equal 177.01. Remember, this is an arc measure, so this is going to be in degrees. So the measure of that arc is going to be 177.01 degrees. All right, so let's go ahead and move on to example 1b here. We'll go to a new page for this one, give us a little more room. And so this one, we want to find the circumference of circle Z. So again, we're going to use this proportion, arc length over circumference equals arc measure over 360. And the first thing we should do again is identify what am I trying to find. So it wants me to find the circumference of circle Z. So circumference is located on the bottom left-hand side of my proportion. So that's what I'm looking for. So when I set up my proportion, I'm looking for the circumference, so I'm going to put that in the bottom, and I'm going to call that x. We need to fill in the arc length and the arc measure for this problem. So let's do arc length first. We look up at the problem, and I'm given 3.44 centimeters. It is listed right here on arc XY, so that is the length of the arc. So we'll go ahead and put that on top. That's the length of the arc. The other thing I'm missing is the arc measure. That's the measure of arc XY. Now, we are given the measure of the central angle, XZY, as 60 degrees. And 60 degrees is going to be the same exact measure of arc XY as well. So 60 degrees is going to go on top here. And we've got our proportion. So just like the previous one, we're going to cross multiply to solve this. So I'll go ahead and start by doing 60 times x, which will just be 60x. And that's going to equal 3.44 times 360, which is going to equal 1,238.4. And then last but not least, divide by 60. 60s are going to cancel. And x is going to equal 20.64. So we want to make sure we give it a proper label. We're finding a circumference. We're given centimeters as my unit of measurement. So go ahead and label that with centimeters. And that's going to be my answer. So we've done 2 examples here. One where we found the arc measure, and one where we found the circumference. We can also do it in finding the arc length given the circumference and the arc measure. We can find any one of these 3 given the other 2. You just need to identify which one you're trying to find and then fill in the other 2 blanks. Cross multiply to solve and then just solve it algebraically from there. If you're having any questions, write them down on the side. Make sure you ask them tomorrow. And have a good day.